Hello, we are from the Roy's Academy faculty team, and today we're going to be learning about something really cool in mathematics. Our course is CBSE Class 10, the subject is mathematics, and we're in Chapter 4, Quadratic Equations. The topic for today is the discriminant and the nature of quadratic roots. Now, for obtaining similar video explainers, please connect with Roy's Academy at 8910-890311. I'll repeat that number. It's 8910-890311. Our other number is 8910-600503. Repeating that one again, 8910-600503.
Okay, let's dive right in. Here's what we've got on the agenda today. First, we're going to take a little peek into the future, of an equation, that is. Then, we'll properly meet our main character, the discriminant. After that, we'll explore the three possible paths it can lead us down, see it work its magic in action, and finally, we'll use this knowledge to solve a really interesting puzzle about a park.
So, what if I told you that you could have a mathematical crystal ball? I mean it, a way to know what kind of answer a quadratic equation has without even doing all the heavy lifting of solving it. Sounds pretty useful, right? Well, that's exactly what we're going to uncover. Now, you probably recognize this guy. It's the powerhouse, the superstar, the quadratic formula. It's our ultimate tool for finding the roots of any quadratic equation. But have you ever really stopped to look at its different parts and wonder what they all do? Because there's a secret hidden inside. That's right. The real magic, the part with all the predictive power, is tucked away right there, under the square root sign. This little piece of the formula, b squared minus 4ac, is the key to everything. It literally decides the fate of our equation's roots. So, this special little expression is so important, it has its own name. It's time for a formal introduction. Think of it as a kind of gatekeeper for quadratic roots, deciding which ones get to exist and what they look like. And here it is. We call it the discriminant, usually shown with a capital D. And it's simply that expression, b squared minus 4ac. Its whole job is to discriminate, or, to tell the difference between the kinds of answers we can get. It's the ultimate decider on whether we'll find real roots or not. So how does this gatekeeper actually make its decisions? Well, it's surprisingly simple. The value of the discriminant can only be one of three things. It can be positive, it can be 0, or it can be negative. And each of those outcomes sends us down a completely different path. And this table sums it all up beautifully. These are the three golden rules. If the discriminant d is positive, so greater than 0, we are guaranteed to find two different or distinct real roots. If d is exactly 0, we'll get two real roots, but they'll be identical, the same number twice. And finally, if d is negative, less than 0, well, you can't take the square root of a negative number in the real number system, right? So there are no real roots. Simple as that.
All right, theory is great, but let's see this thing in action. The best way to really get a feel for these rules is to just jump in and test them out. Let's do a couple of quick examples.
Okay, first up, we have the equation 2x squared minus 4x plus 3 equals 0. Our mission, should we choose to accept it, is to figure out the nature of its roots without actually solving for x. All we need is our new friend, the discriminant. So let's walk through it. Step 1, we identify our coefficients. Here, a is 2, b is negative 4, and c is 3. Easy enough. Now, step 2, we plug them into our discriminant formula. So d equals negative 4 squared minus 4 times 2 times 3. That becomes 16 minus 24, which gives us negative 8. And of course, negative 8 is less than 0. And what did our rules say about a negative discriminant? It means there's no path forward for real solutions. So we can say with 100% certainty that this equation has no real roots. And look at that. We figured that out without touching the rest of the quadratic formula. Pretty neat, huh?
Ready for another round? Let's make sure this really sinks in. Our next equation is 3x squared minus 2x plus 1/3 equals 0. What's your prediction this time? What kind of roots are we going to find?
Let's run the play again. Our a is 3, b is negative 2, and c is 1/3. We calculate the discriminant. d equals negative 2 squared minus 4 times 3 times 1/3. Let's see. That simplifies to 4 minus 4, which gives us a big ol' 0. A discriminant of 0 means we're on that second path. It tells us that this equation has two real roots, but they are exactly the same. And just to confirm, if we were to solve it all the way, we'd find out that both of those roots are 1/3. Okay, now for the really cool part.
Let's see how this powerful little tool can be applied to a real-world problem. This is where you realize that concepts like the discriminant aren't just for a math test. They can actually help us figure out if something is even possible in the real world.
So here's the puzzle. Picture a circular park. It has a diameter of 13 meters with gates at either end. We'll call them A and B. We need to install a pole, let's call it P, somewhere on the circular edge of the park. But there's a catch. The difference between its distance from gate A and its distance from gate B has to be exactly 7 meters. Now, before we start trying to draw diagrams or do complex geometry, the most important question we should ask is this even possible? Can we actually find a spot for this pole that meets all the requirements?
Well, it turns out that by using a little bit of geometry, specifically the Pythagorean theorem, we can translate this entire word problem into a single quadratic equation. If we let x be the distance from one of the gates, the whole situation boils down to this: x squared plus 7x minus 60 equals 0.
And here's where we get to be clever. Instead of solving this equation for x, let's just use the discriminant to check if a real solution, a real distance, even exists. If it does, the puzzle is possible. So, for our equation, a is 1, b is 7, and c is negative 60. Let's find d.
Okay, let's crunch the numbers. d equals 7 squared minus 4 times 1 times negative 60. That gives us 49 plus 240, which lands us squarely on 289.
And what does a discriminant of 289 tell us? Well, it's positive, right? So d is greater than 0. This confirms our equation has real roots. And that means the answer to our puzzle is a definite yes. It is totally possible to place that pole.
And just to wrap up the story, if we did solve the equation, we'd find that the valid distance for x is 5 meters. That means the pole should be placed 5 meters from gate B, which would make it 12 meters from gate A, and the difference is exactly 7 meters. Perfect.
So you see, the discriminant is more than just a piece of a formula. It's like a feasibility check. It tells us if a solution is even possible before we waste time looking for it. It makes you wonder, doesn't it? What other real-world problems, maybe in design or finance or even physics, could you test for possibility using this simple, powerful tool? This was an initiative from the ROS Academy faculty team, and today we've learned about the discriminant and the nature of quadratic roots for CBSE Class 10 Mathematics. For obtaining similar video explainers, please connect with Roy's Academy at 8910-890311. I'll repeat that number again, 8910-890311. Our other number is 8910-600-503. Repeating that again, 8910-600-503. Thank you